6/9 now. Didn't make any mistakes there, did we? Hey folks, welcome out there this afternoon to Tea and Learn Mathline. We are so glad you've tuned in to join us today. It's summer school time here at Tea and Learn Mathline. So it's not a live show today, but what we do, we're going to allow you to still send us email, Facebook, all sorts of good things, comments, questions, and we'll address them on later shows. Hope you've had a great summer so far. It's hard to believe it's moving so quickly here. But you know what? We're still got a few more weeks to go. We're going to be hanging in there with it. By the way, I'm Ernie Roberts, and I am your host for today's version of Tea and Learn Mathline Summer School. And again, thank you for tuning in. And let's see what we're going to be talking about today, ladies and gentlemen. We have, oh my goodness, it's summer school. We said that, right? The good stuff. That could almost be anything. But you know what it's about today? It's about mixed numbers. We're going to multiply and divide. So that, I call it the good stuff because I think it's a little bit easier than when you had to work with common denominators or regrouping subtractions, which we've already covered this summer. But this one is a little bit easier fare today, all right? So let's take a look at the type problems we're going to be looking at. We're going to be mixed numbers, also a few fractions thrown in, and hey, can't forget those rational numbers that are integers or whole numbers that we're going to multiply into those mixed numbers. So let's see a good example of what we got going here. Let's see what we got. Couple of examples actually here. So we're going to multiply these fractions. Now, review, rehash, remediation. So we're not really picking these up from the start. Now, some of you may be tuning in and say, well, Ernie, I've not done fractions before. I'm learning how to do them for the first time today. That's great. We will take it in that respect. But we will also be moving along at a pretty quick clip today, all right? Because we want to get a lot of problems in and a lot of chances to see, oh, these really aren't that hard. And they aren't. So the first thing we got to worry about here is this 3 1/3 when we multiply by 12. Now 12, remember the rule, simple rule is it is rational. It can be written as a fraction. And there we have it, all right? So now we definitely are going to multiply these fractions, all right? So we've got 12 over 1 times 3 1/3. Now let's fix 3 1/3. In fact, let's fix the whole thing. By the way, we encourage you to write these down at home and work them out with us, all right? So get your pencil, get your paper, and let's be writing down along the way as I go through the problems with you. Let's bring this 12 over 1 right down there and put a multiplication sign there. That's what that little X is standing for, is multiplication today. What we need to do, I said, mention the word improper fraction, all right? Because what we need to be able to do is say a strict numerator times numerator and denominator times denominator situation to multiply two fractions. This obviously has a little bit of, could be confusion, all right? Now you can write that in a distributive property type fashion, 3 plus 1/3, and then run the 12 through the 3 and run it through 1/3. That's a little bit complicated. It takes a little bit of time. Let's just make it one nice improper fraction, all right? And it is nice in this case. So we're going to say 3 times 3 gives us 9. Add the 1. Now remember, 3 times 3, take the whole number part of that mixed number, multiply it times your denominator, then add the numerator to it, and that becomes your new numerator, which in this case is 10. Remember, 3 times 3, got it 9. Add 1, you get 10. Y'all with me? Everybody out there? Good. And you keep that 3 in the denominator. It does not go away because we now have, instead of 3 1/3, we got 10/3, which just means the same thing as 3 1/3. All right, it's just written in a different fashion. Now, where can we go from here? I see cancellation waiting. Now, some of you said, well, I thought you said we're going to multiply numerators. We could do that. But you know what? 12 times 10 gets kind of big. It's 120. Granted, it has a 0 on the end, which doesn't make it quite so hard to deal with, but it's a big number. We can get things a lot easier for us if we will notice on this diagonal, 3 will divide into both 3 and 12 evenly. So let's slice it and dice it 3 ways. 3 divides into 3 one time, so bring your 1 down there. And up here we've got 3 dividing into 12. It's going to go 4 times. So you're left with a 4 times, got it, 10. And that's going to give us 40. 4 times 10. Now we multiply our numerators together. It's over 1, so that's going to simply leave us with 40. We can write that in that fashion. Now, over here on the other side, a little practice moment, all right? We've got 20. Guess what? We're going to put a 1 underneath that. We'll go ahead, and that was easy. Wasn't that easy? That was so easy. Now, what we're going to do here is take 4 2/5. We're going to change it into an improper fraction, make life easier on us. 4 times 5, how about it? Yeah, it gives us 20. Add the 2, got 22. So let's put 22 over 5, and we're going to multiply that creature by 20 over 1, all right? Now, life looks good there. Life looks good because you know what? You say, my goodness, Ernie, you got big numbers in those numerators, don't you? And if we multiply them, hey, we can get, what, 440? And you can go like, woohoo, big numbers. But you know what? We've got a way to make this work easier. Again, do the same story here. Cancel with the 4, with 4 coming up after you divide 5 into 20. So again, we're going to cancel the 5 and the 20. And that's going to give us, how about it? Slice it 5 ways. We get a 1 here. Slice up here. We get a 4. And what does that give us for a final answer? Well, you got it. 22 times 4. You can do that in your head. You can do that in your head, guys and ladies out there. All right. That's going to give us, looks like 88 over 1. Once again, multiply numerators together. Multiply your denominators together. Remember, numerators on the top, denominators on the bottom. Multiply those together. Now you can multiply across. Never cancel across, by the way. Just multiply across. You get that 88 over 1, which is just simply 88. And you say, well, Ernie, will it always come out a whole number in the end? No. It depends on the fractions that I chose here. I chose these because I wanted you to see some cancellations that can make life easy for you. Sometimes you don't have that luxury. Sometimes the numbers just are what they are, and they don't disappear in the denominator. That's when you come up with your mixed numbers to end up your final answer, okay? So we'll see some of those pop up today. It's not going to always come out pretty city here, all right? It's got sometimes going to have some messy looking fractions. We just can't avoid those. But you know what? We're going to take care and see what we can get through today, all right? So, hey folks, in case you're wondering, you're with TN Learn Mathline. It's not a call-in day. We're talking fractions today. We're talking about division in a few minutes. We're also talking about multiplication right now, all right? So let's take a look at some more multiplication problems here. And we're working with fractions and mixed numbers today, all right? Let's see what we've got here. Multiply and simplify. That's in case we can just what we said, reduce, simplify in the end. Let's see what we've got going here. Hopefully some cancellation because these numbers are starting to look a little bigger. Notice we have a mixed number. Hey, we're going to make it improper, all right? That's the best way to do it. We have 5/8. You say, well, that's kind of, we don't know if we like that or not, do we? Well, let's see. We may not have to worry about that 5/8 as being an 8 and a 7. I see this 8 times 7, it makes me nervous, but we can't do anything until we make that improper, all right? So let's go with it. 3 times 7 gives us, hey, that one's easy, your times tables. That's why you know your times tables for fractions. Oh my goodness, they're so helpful. You've got 3 times 7, which is going to give you 21. Add the 3, we're going to get 24 over 7. Everybody see that again? Take this 3, the big 3, okay, the whole number part of this mixed number. Take the 3 times the 7 in the denominator, it's 21. Then add that numerator and put the 24 back over the 7. That's what we got to remember to do. Now, on the other side here, we're going to multiply 5/8. That doesn't change because it's set and ready to go. Numerator's in place, denominator's in place. You don't need to worry, all right? Now, what can we do to make this look a little easier? Because I don't really care about, well, we may care about it. I got 7 times 8 in the denominator, which is going to be 56. Whew, I've got 24 times 5, which is going to be 120. Folks, that's some big numbers. Let's reduce if we can. You say, well, how do we reduce if we can't? Look on that diagonal. Look for the cancellations, all right? So I see 8 and I see 24. I know my times tables. I know my multiplication facts. I know that 8 will divide into 24 evenly. Life will be so much better. How much better? Let's take a look. We can divide 8 into 8, split it up, goes 1. Divide 8 into 24, goes 3. All of a sudden, what looked rather nasty is not so bad. It's not so bad. We've got 15 over 7. 15 over 7, because 3 times 5 gives us 15. 7 times 1 gives us 7. Woo, life is much better. Life is much better. Now, how is that going to simplify? Because that's the second part of this process. We got to simplify. So we're going to make it into a mixed number. Since we start with mixed numbers, we like to finish with mixed numbers. And we simply divide that 7 into the 15. That's the idea. Because remember, a fraction is simply division. 15 over 7, or 15/7, is the same thing as saying 15 divided by 7. 7 goes in there 2 times. 2 times 7 gives us 14. Have 1 left over. I'm getting 2 and 1/7. So the final answer here, 2 and 1/7. Remember when you're doing this, you divide the 7 into the 15, it goes 2 times. That's the integer part. That's the whole number part of the mixed number, all right? Now, what's left over? After you say 2 times 7, 14, that's the 1. That occupies your numerator, and 7 was in the denominator. It stays in the denominator. It remains there, and that's your story. That's where you're going to work with these, all right? So that's how they deal. Next problem, while we're at it, a little practice. This time the 2/3 came first. That's fine. It's no big deal. It's no big deal. Let's make an improper fraction happen here. And hopefully again, because I'm seeing 6 times 4, and then I'm multiplying, I'm multiplying that, and then I'm adding 3. Oh my goodness, that's going to be a big number. So let's check it out. 6 times 4, as I said, we're going to multiply. 24, add the 3. That gives you 27. Now you're just doubling 27. So that's not so bad, but you know me, Ernie Roberts, I want to look for some things that make it easier. You want to look for things that make it easier, right? Everybody out there know it. So let's take 3 into 27. I like the look of that. 3 will divide in there 1 time. And how about it? Here, 3 will go into this 9 times. Already this looks easier. Already this looks so much sweeter. So much sweeter. Let's see where this is going to take us. Interesting. We got another cancellation, folks. We got a 2 and a 4 going here. Wow. 2 will go into 2 1 time. 2 will go into 4 2 times. I see 9 divided by 2. 9 halves. 9 over 2. All those great ways. So let's see. We can do that mentally. Can we do that mentally? Sure we can. Divide 4 goes 4 times. Yeah, 2 goes into 9 4 times, right? And you got 1 left over because 4 times 2 is 8. So again, we're going to do just like we did over here. We're going to do this mentally. I see 4 popping up. That's what I said a minute ago. And I have 1 left over. And put that over 2. 4 and 1/2. And again, it's just simply division. Remember, that's what 9 halves, or 9 over 2, 9 divided by 2. That's what a fraction tells us to do. It's simple division. And that's where we end up with our mixed number at the end. Not bad, is it? Not bad at all. Not bad at all. So 1 or 2 more practice problems. You know, so far I've given you a mixed number times a fraction or a mixed number times a whole number. You know, you can have a mixed number times a mixed number. Let's take a look at it here. And this is one where it really becomes important to have those improper fractions going in your direction, all right? So let's fix this one and see what's going to happen to our next problem here. I've got 1 4/5. 1 times 5. Give us a 5. Add 4. Pick up 9/5. All right, make it improper. How about it? Our second fraction mixed number problem here. How about it? 3 times 3. You got that. Gives you 9. Add 1. Ooh, we're up to 11. You see what I mean? If we had to do 9 times 11, we get 99 and 15 in the denominator. That's that's not easy, okay? But boy, just a simple division right here brings this so much under control. 3 times 11, got it, 33. The 5 is underneath. Let's divide 5 into 33 and see what happens. Again, I think most of you can do this mentally. I'm just going to run it through just for the fun of it. Let's see. That goes in there 6 times. 6 times 5 gives us 30. Let's subtract. We're going to do that. We got 3 left over. And remember, that gives us 6. That's the whole number part of the mixed fraction. And we got a 3, and bring that denominator that you had 5 right over there for the ride. So there we go. That's where it ends up. 3 left over, 6 3/5. Easy, isn't it? I told you it was going to be easier. I think it's easier to do multiplication and division than it is to add and subtract. But all processes, all 4 of those are easy once you learn your business on it, okay? And practice. You got to practice on it some. That's the thing that makes you good at it. So let's take a look at our next 2 problems here. More multiplication. We're going to get to division. Promised you we're going to be multiplying and dividing today. But, you know, if you can multiply, division is easy. Got to remember one little step. So let's work the multiplication, make sure we're good on it, and we'll go from there. See what we have here. All right, 2 3/4. Are you already working it out at home? I hope you are. Improper fraction time. 2 times 4, got it. 8, add 3. I see 11 over, put that 4 back. Remember, we always keep the denominators the same. They just don't change. It's the numerator that's adjusting when we do an improper fraction, all right? Let's multiply this one out. Ooh, 1 times 11, that one's easy. I keep saying that, don't I? And let's add 3. Well, my friends, what do we have? 11 plus 3 is 14. And put it back over 11. Now, I'm going to tell you right now, you want to notice there's a major cancellation going on right here, because I don't really want to figure out what 11 times 14 is, and I sure don't want to divide 44 into it, all right, and see how many times it goes. I've got ways to get out of this. And you said, well, Ernie, you said sometimes it does. Yeah, sometimes we don't get that luxury, but today I'm going to try to help you through with that, all right? We want to see these things cancel. By the way, when they cancel, we're left with 1s here. And this one is a little different. We can't take 4 into 14, but you can certainly divide 2 into both of these. It's going to leave you with 2, and that's going to leave you with 7. We don't want to forget, sometimes we can't just knock them out completely, but we can reduce them somewhat, and it's certainly easier to deal with 1 times, you got it, 7, and 2 times 1, which is 2. Oh, that one's real easy to do. Mental math time, folks. That's going to give us 3 and 1/2. And that's interesting because we started with fourths, we multiply by 11s, and we end up with halves. That's the beauty of these fractions. The numbers are really cool, because what happened here was what happened when we got to these improper fraction forms. Well, kicked in the numerators. Sometimes they'll work, sometimes they don't. All right, this time it worked out really nicely. Hope this next one is going to do the same thing. Let's take a look at it. 3.5. Y'all already on it? I know you are. Let's kick it and go. 3 times 2, 6. Add 1. 7 over 2. All right. Do the same thing over here. 3 times 7, 21. Add 1. I get 22. You know, that's that supposedly fractional approximation. Not exactly, but that's that fraction for pi, just in case you were thinking that sounded familiar. It does. 22 over 7 is kind of what we use as our, quote, rational integral approximation, because it's still not exactly pi, but it's pretty close, pretty close. Just a little reference there. Speaking of which, let's see what this is going to do for us. I see some nice things coming. I see 7s that are saying goodbye. I even see, can you see it? I see it. We all see it. 2 into 22, sweet. 11, 1, because 2 divides into both those evenly. Everything is awesome, right? Let's have it. 11, and we can put over 1. You know what? Doesn't matter, does it? 11 is your final answer there. Over here we had 3.5. Again, when you can reduce those fractions from the get-go, it's nice. But remember, you can't reduce until, got it? Until you make them totally in improper fraction form. Can't do any cancellations or things like that. Don't try to jump in there too soon. Get to the improper fractions, then full speed ahead. All right? Good stuff out there. Good stuff. So we've multiplied. Let's divide. Let's go through the division rules real quick. And I told you they're very similar to multiplication. There's one catch. First of all, we need a 1 underneath there. That's going to be our first thing that we're going to notice. And we're going to put it 4 over 1 divided by, we want to fix, again, make an improper fraction. Improper fraction, because we need a numerator over the denominator, not this mixed business, okay? So let's see what that's going to do for us. You say, what is it going to do for us, Ernie? It's going to give us 1 times 3, add 1. We get 4 over 3. Now, you say, what do we just multiply? It says divide, doesn't it? We have to change, remember, we have to change when we're doing division, we have to change it to a multiplication. So we're going to keep 4 over 1. First number never changes. Keep the 1 under there. It'll help us guide. It'll guide us there. And the 4 over 3, we're going to use its reciprocal. And you say, reciprocal. I've heard that word. You've heard it a lot on Mathline. Those of you who tune into Mathline daily, you've heard it quite a bit. The reciprocal is when we interchange the numerator and the denominator. So in other words, what is 4/3 becomes 3/4. And since we're using reciprocal, which is the inverse operation of, is an inverse operation for multiplication. We're using the reciprocal because if we were to multiply those together, we would get 1. But doing that, we've got to go to multiplication. So in other words, inverse of division, that's an easy way to remember this, is multiplication. The inverse reciprocal part, which we're talking multiplication inverse, is 3/4. That's where you are, all right? When we think of addition inverses, we're thinking of opposites like positive 2 and negative 2. But when we do multiplication division, we're talking about reciprocals. That's the multiplication inverse, and that's where we go. We multiply by the reciprocal, the inverse. You've heard the word invert and multiply. Reciprocal's the nice, good R word, okay? And we've used a lot of R words here right this week on Mathline with all of the remediation, review, rehash, refresh, all sorts of things that start with re, all right? And this one is reciprocal. We like that one too. Now, we've done a little division. Let's practice just a tad. Let's practice a little bit. What happens when we put the 4, when we're going to divide it 4 ways? So we start with 2 1/8, and remember, oh yeah, everybody's saying, we still do what we need to do. So here we go. And you say, what is it we need to do? We need to make improper fractions, right? So how about it? 17 over 8. How to get that? 2 times 8, add 1. 17 over 8. Mental math, right? Let's go ahead and put a 1 under that 4, and let's just go ahead and say we're going to do the reciprocal. All right? You want to see divided by? I'll put divided by there. All right? 4 over 1. And I put that 1 underneath there because the reciprocal of 4 is going to be 1/4. All right? 1 divided by 4, 1 over 4. So we've got 17/8 times, run that reciprocal. And this time, hey, I gave you one that didn't have any, doesn't have any cancellations, do it? Do we? All right, let's see it. Let's just do it. That's what we got to do. So we're going to take 17 times 1, which is 17, and 8 times 4, 32. 17 30-seconds. A little bit more, just a little bit more than 1/2. Just a little bit beyond 1/2, all right? So there's your story right there. Now, let's go over here. People, pay close attention. Yes, yes, yes. We're going to go ahead and make that improper. How about it? So we got 3 times 5, which is 15. Add not 1, but 2. 17 over 5. All right, everybody good so far? Remember, keep those denominators lining up. And we'll keep the divided by 1/10. Haven't changed anything yet. Always make your improper fractions first, then think about what are we going to do with the division. Remember, inverse operations, we're going to multiply and we're going to use a reciprocal. So we're going to keep 17 over 5, 17/5. Then we're going to multiply, woohoo, by big numbers here, 10 over 1. So it's basically like we're taking this thing and dividing, like into, and not dividing, but multiplying into, looks like a lot of pieces. A lot of pieces there, all right? So let's kick it out and see where it goes. What's going to happen here? You see, I see, we all see. How about it? Divide 5 into 10. Goes 2 times. And we end up with 34. And that is interesting because remember, when we multiply by 10, it's the same thing as dividing by 1/10. Or when we divide by 1/10, it's the same thing as doing what? Multiplying by the reciprocal 10. So be very careful. All right, be very careful. It's tempting because you're sitting there, you're thinking dividing by 1/10. But it's not like we're dividing by 10. If we divided by 10, that would give us much, much smaller pieces. All right. But basically, by dividing by 1/10, we're multiplying. We're increasing how many pieces we have here. And it actually gets us to 34. So interesting. Be careful with your division. Because sometimes those answers almost look, I don't get that. But it's because, again, it's the reciprocal effect. Watch out for it, okay? Watching out. Let's do one quick one here to get us off the air, all right? Let's take a look at this one. 2 mixed numbers ready to be divided. Maybe we'll have some cancellations going in it. We'll check and see. First of all, what have I said? Improper fractions. This is your exit out the door moment, all right? So we get 3 times 2, which is 6. Add 1. How about it? Goes 7 halves. Let's go ahead and keep the divided by. Don't mess with it yet. We got to get improper fractions here. How about it? Let's see. 2 times 4 catches 8. Add 3. I see 11. 7-Eleven. I'm sorry, there used to be stores called 7-Eleven. I don't even know if they're even around anymore. And what are we going to do? Are we going to leave it like this and multiply? Not yet. We're going to multiply, but we're going to change which one? Not the first, but the second fraction. Use its reciprocal. So 7 halves, go to multiplication. Always keep the first fraction the same. Reciprocal time, you know what that is. Interchange denominator, numerator. It's going to be 4 over 11. I do have a little bit of cancellation I can do here. I can run that 1 and 2 right there because 2 divides into 2 evenly as it does into 4 evenly. And I end up with, oh goodness, 14 divided by 11, or 14 11ths, 14 over 11. We all like to call them so many different ways. And it goes in there, guess what? 1 time. How many left over? 3. And which number are we going to put it over? Which number are we going to put over? You got it? 1 1 11. And that, folks, is what happens, all right? So, hey, we went from halves and fourths to 11ths. How funny is that? Fractions, math, some good stuff. The good stuff, remember we said that was going to be today. And it's good stuff that you were tuned in today with us. And you know what? We'll see you again next time. See you then.